डॉक्टर बाबासाहेब आंबेडकर ओपन यूनिवर्सिटी.
Dear students, I, Dr. Shivang Patel, Associate Professor from School of Computer Science, Babasaheb Ambedkar Open University, welcome you all in the lecture series of Subject Operating System from Chaitanya Studio of Babasaheb Ambedkar Open University. In the lecture series of Operating System subject, we have discussed various commands related with process. We have already seen what is process, how the process is created, how you can track the status of the process. We have already discussed PS command with all the options. Now in today's session, we are going to start the unit called inter-process communication. Now today's agenda, you can see after completion of this unit, you can able to understand basics of inter-process communication. Use different commands like mail, finger. These are the commands related with communications that you can able to perform. And third one is telnet command. Basically, if you want to connect some remote system or remote PC, in that case you are using this command telnet. So this thing that you can able to do after completion of this unit. Now we are starting with the concept called inter-process communication. So now you can divide this term IPC, that is inter-process communication. So processes are communicated with each other internally. In normal terms, you can say that. Now why this communication is required? Because whenever any task or any operation that can be performed, that can be divided among multiple processes. You already aware the concept of process and threads, right? So your task or whatever the operation done by the user or some of the operation that can be managed by the system, they are divided into multiple processes, or you can say that the multiple threads. Now how the state or the track of multiple processes, whatever the task that can be done, that can be managed. So this process or this task that can be managed by communicating among multiple processes. So one process can communicate with another process regarding whatever the resource availability, what is the current state, which are the operations that can be performed, what are the tasks that are remaining, any of the task or any of the condition or any of the scenario that will be discussed among multiple processes, and that is broadly considering as inter-process communication, right? So in short, you can say that multiple processes are communicating with each other to perform a single task or to perform a multiple task. Now they are communicating by using multiple ways. So you can say that processes are divided into basically two types. One is independent processes and second one is cooperating processes. Now understand these two terms. What is independent processes? So processes which are not related with each other, they will be considering as independent processes. What means that? Suppose one process that can be executed, then after some output will be generated. At the same time, another processes are available in the queue, but whatever the operations performed by that first process, that cannot affect the operation of the second process. Or you can say that whatever the results of one process, that cannot affect the another process. They are executing independently without sharing of any of the resources or without passing any data, without passing any message between multiple processes. They are considered as independent processes. Second type of processes, you can say that the cooperating processes, that is the core of this topic, that is inter-process communication, in which one process communicate with another, or you can say that more than two processes are communicating with one another, because whenever the operation done by one process, some of the result that may affect to the another process, or some process that may pass whatever the message to the another process. This way multiple processes that can be communicating with each other, right? Now we are discussing basically this can be done with the help of share memory and the message passing techniques, different mechanisms that can be used. Now we are going to do in the deep concept of IPC, but before that you can understand some basic terms. First term, that is pipe. So pipe, that you already aware in our previous sessions, that you have already aware that pipe that can be used for redirection purpose. To merge multiple commands, you are using the pipe symbol. Now example that you already aware, say for example one command that you are executing, the output of that command that can be used as an input to another command. This way multiple commands, they are combined. Now here we are talking about the commands, but in the case of inter-process communication, you can consider that command as a process, right? So in that case what happen, one process can execute whatever the output that can be passed to the another process. So this way multiple processes are related, or you can say that the interrelated, right? So there the particular operation having no name, or there is no particular memory available for that having some name, that's why it is considered as unnamed processes, right? So whatever the operations that can be done with the help of some buffer. Buffer is nothing but some temporary space that can be allocated when execution that can done. So whenever the one command will be executed, output will be stored in the buffer, and another command will take that output as an input from that particular buffer. That's why pipe is considered as unnamed process, right? That is one scenario. You can see the example, that is who and wc-l command. Now who command, when it will execute, it will display the user logged in the system, that will be displayed. So whatever the users list that can be passed to the next command, that is wc, and that wc command will count line. This way you can count total number of users that are currently logged in the system. So here whatever the output generated by the who command, that will be stored in the buffer, and the output will be used as an input by the wc command. So this way pipe will work. That is nothing but a normal or simple example of inter-process communication here, in which multiple commands, or you can say that the multiple processes, they are communicating with each other by passing some data. Here in our case, they are passing their output, and the resource that can be used, that is nothing but the buffer. Second concept, that is FIFO, first in first out. Unrelated processes, as we have discussed, whenever one process is executed, another process cannot affect by one or another way. They are totally executing independently. So in that case you are using this concept FIFO. The basic difference between pipe and FIFO is that in pipe that is no name, that's why it is called unnamed process, while in FIFO the process having some name, so some name you have to give, that is named pipe, right? Now multiple processes that can be passed whatever the content or whatever the message is in the case of pipe symbol, but here one queue will be generated, and that queue that can be accessed by the multiple processes. So that is the concept called FIFO. You can create a FIFO with the help of function mkFIFO in the Linux or Unix operating system, right? So these two concepts that we have discussed. Now the next is message queues. Now basically whenever you are talking about IPC, inter-process communication, so generally this mechanism uses three methods. One method is message queue, second one is shared memory, and third one is semaphore. You can see with the help of command, that is I am executing IPCS. So whenever you are using this command without any argument, in that case you can able to see three different mechanisms for message passing techniques. So first is message queue, in which queues will be generated by one process, or you can say that the system or the kernel, and other clients or other processes that can access that particular queue and exchange their messages. That is one of the mechanisms. Here you can see the data or information with the help of IPCS command. For each and every mechanism, there is unique ID available. Say for example of message queue, MSQ ID will be there. Second mechanism, that is shared memory. How it differs from the previous one? In previous case, the queue will be generated and the processes that can be accessed or exchange messages from that particular queue. But here some memory area that can be shared among multiple processes, you can say that the memory segment that can be shared among multiple processes. That's why it is considering as shared memory segment. Here also you can identify with the help of ID. Then after third one is semaphore. Here the lock mechanism that can be used while multiple processes use some common resources. As you already aware, the concept or the formulate called deadlock in your operating system theory portion. While deadlock will occur, all the processes that stops that execution because of lacking of resources. So in that case, semaphore that can be the solution in which you can lock your resource while some of the resources that can be shareable among multiple processes. So all these mechanisms we will see one by one in detail, right? So we have discussed message queues in which queue will be generated and the messages that can be passed in the form of exchange of information among multiple processes, right? So the option that can be used, that is -q. Generally without option, all three mechanisms that will be displayed. But if you want to show only active message queues, in that case you can use the option q, right? Second mechanism that you can use, that is shared memory. Now what is shared memory segment? So you can get more idea with the help of this diagram. Suppose in the diagram here, two processes are there. One process A, and second process, that is process B. Process A having its own private memory or private address space, and same way process B having its own private address space. Now suppose some of the portion that is shareable, that is the concept just like the global variable that you already aware in any programming language, that global variable that can be shareable among all the functions throughout the program or outside that, right? So same way here, that shared memory segment that can be managed by the operating system or managed by the kernel, and multiple process here in this example, two processes, process A and B, that can share that particular segment. So whatever the message or the data or the content or whatever the information that can be passed through this shared segment area, right? This is the second mechanism that we have discussed. First that we have already discussed, that is message queue, in which queue will be generated and by some particular process, and multiple other processes, say for example client processes, that can use that queue. Second mechanism that we have discussed, that is shared memory. Now suppose you want to show all the active shared memory segment. In that case you can use the option called M. In previous case, if you want to see the memory queues, then you can use the option Q, but here you want to see the shared memory segment. In that case you can use M option, right? These two mechanisms that we have covered. Now the third mechanism, that is semaphore. Now what is this semaphore? It is nothing but you can say that one state or one variable, and generally two methods that can be used by this semaphore. So when it will be used, so as we have discussed, inter-process communication, that means some of the resources that can be shareable among multiple processes, right? Now suppose there are multiple processes and the resources are limited, then how resource will be allocated to whatever the process is available in the execution. Suppose proper management is not there, in that case deadlock condition may occur. So there is one situation, there is one condition, or there is one solution, you can say that the semaphore variable, by which you can lock that particular resource. Now whenever the one process that use that particular resource, by locking that particular resource, another process must have to wait till that process 1 executes with the help of that particular shared resources. When that process is successfully executing, then after that resource is released and it will be available to the another process. Now this way you can share the resources and you can prevent from the deadlock condition. So that's why we are using that semaphore. So to see all the active semaphores, you can use the option S, right? We have already discussed two options, Q option we have seen, M option we have seen, S option that you want to see the active semaphore, in that case you are using. Now two methods that can be used here, or generally two semaphores are there. One is binary semaphore and another is countable, or you can say that the increment decrement semaphore, in which the value that can be changed. Now two methods, up down and the lock unlock method, that can be used. So basically it is binary semaphore, only two values are there, 0 and 1. You can say that some of the resources that can be allocated to particular process, in that case the wait operation that can be activated. So another process can get the signal wait. So it means that that particular resource is already allocated by a particular process. So when this process is successfully completed, then and then that resource will be released, and then after the signal, or you can say that the semaphore value that can be changed from 1 to 0, now another process will use that particular resource, right? So this way you can acquire the resource with the help of semaphore. So that is the binary semaphore. Second type of semaphore, that is counting semaphore. Here number of resources based on availability, adding or removing the number that can be changed. Suppose in the queue, suppose the resource will be added, then the semaphore value that will be automatically incremented. If the resource that can be removed from the queue, then this value will be decremented. So this way counting semaphore that will track whatever the number of resources that are available for execution by multiple processes. Now we are moving with some detail that IPCS command. So basically this will display the information about whatever the inter-process communication mechanisms that we have already discussed. Three types of mechanism, that is message queue, shared memory and semaphore, right? So we can see one by one options. First option queue that we already seen, active message queue. If you want to display M, that is for active shared memory segment. If you are using S, then it will display the active semaphore values. Then after B, that is allowable size. Now in queue multiple messages are there, then what is the size for that particular message, that will be defined by here this B option. B, that is for byte, right? In the case of message queue, mind well, if first mechanism is used message queue, in that case B represent the size in bytes for particular message. If you are using another mechanism, that is shared memory segment, in that case that B indicates the memory size or shared memory segment size here. And in the third case, if you are using the semaphore, in that case number of semaphores that can be available, that will be represented by this B option. So according to mechanism, the value indicates that which mechanism that you are going to use. C, that is creator's username or the group name. P, that is the process number, as you already aware, because multiple processes or more than two processes are communicating with each other. Which process is last running, or which process have sent the message, or which process have received the message. How you can track that? With the help of this process ID. So with the help of P option, you can get that process ID that can be actually used in the operation. And T, that means the time information, whatever the communication occur or done, which time frame that can be elapsed or used, these information that can be used. So this is all about the IPC. Now we are moving with the mail command that you already aware. You have already used the mail client, that is Microsoft Outlook, but here in Linux or Ubuntu operating system or Linux or Unix operating system, there are special commands that can be used for communicating purpose. If you want to send mail to some user, in that case mail command is used. Basically it is used for writing automated scripts. Say for example, suppose you want to perform some automation task, like you are performing periodical backups. When the backup will be completed, automatically mail will be sent to that particular user. Such kind of mechanism you want to cover. In that case, you are using this automated script with the help of mail command, right? So normally you can see on the screen the example is given, mail, that command is used. S option, that is for subject. In double inverted comma you can mention the subject, then after the user mail ID that you have to pass, for which you want to send that particular mail. Then after it will ask for CC, that is the carbon copy, and it will ask for the message, right? Now multiple options that you can use with the mail command. V, that is verbose information, whatever the message sent, the delivery information that you can able to see with the help of this particular option. S option, that represent the subject. Then after C, that is for carbon copies. If you want to send mail to multiple users, in that case you are using this CC option. Now BCC option is just like blind carbon copy that you are using in normal mail applications. Then F, that is read the contents of the mailbox. If you want to read inbox, you can say that the mailbox. In that case, you are using the option called F, and R that specifies from address. Generally, we are using the mail command. In that case, we are not identifying, we are not passing that particular from address, but explicitly you want to pass that particular address from address. In that case, you are using this R option, right? We can see one example so you can get more idea. Sending sample mail. So echo mail body. Suppose your message body is not so lengthy, it is quite small. In that case, you can use the echo command. Then after pipeline symbol, as we have discussed, it can use to merge multiple commands. So whatever the output of echo command, that can be passed to the mail command. Here the subject that can be mentioned with the S option. Then after user@user.com, that is the mail address or valid email address for which you want to send particular mail, right? Then after, it will ask for whatever the message you want to type. You can type your message and then after press Ctrl D. So your message will be completed or stopped and the mail will be sent to that particular user. Now specifying body in the file. So in previous example, we have seen using echo. But if your message is lengthy, then it is quite difficult or it is not a convenient way to use echo command, right? So in that case, whatever your message, you can create one file, one txt file or any other file, and you can use as a redirection with the mail command, right? So we are creating one message and giving that file name body.txt. Now we have to pass that message by using the mail command. So you can pass here mail, then after S, that is for subject, mail subject, you have to write in inverted comma. Then after user1@example.com, user2@example.com. So this way you can pass that particular message or mail to multiple users by using comma separated values. And then after, here less than sign, that is nothing but the redirection. Body.txt, that is the file in which we have saved our message. That message will be passed here in the mail command and the mail will be sent with that particular subject name and with that subject body to these two users, right? Now using CC and BCC option, so you can use the option C for CC and you can use the option B for BCC. So here you can see on the screen the example is given, mail subject, then after C, whatever the mail ID you want to put into the CC, you can mention C before that mail ID. Then after same way you can use B for BCC. Then after other methods are same. If you want to pass any the message body that is available in some particular file, then you can pass with the help of this redirection, right? Now specifying the from address, as we have discussed, normally mail command, it is not required to use that from address, right? But specifically externally you want to specify, you can use that particular with the help of F option, right? Now cat body.txt, that is the file that can be passed to mail. S, that is for subject, to user, that is the mail ID for which we want to send the message. Then after we have to specify from externally with the help of option R, right? So this way you can send. Second thing, if you want to attach some file in this mail command, so it is not possible directly. You have to use some another command, that is encode command. You have to use pipeline symbol. So encode command you have to use. Then after whatever the attachment file, that name or path that you have to pass, then after you can use pipe command. So this way you can merge these multiple commands and you can pass the attachment from one command encode to mail command, right? Then after reading emails, the mailbox or inbox, that can be read without passing any option. In previous case, if you want to send any mail, in that case you are using different options like subject, CC and BCC like that. But here if you want to read your inbox or mailbox, in that case you don't have to pass any of the option. Normally you have to use that mail command. So whatever the mails available, that can be listed out here. Or another alternative is that suppose there is one file or directory available in the Linux that can store all the mail in the mailbox. Normally in the spool area or the mail folder will be there. You can pass this command with the help of F option to read the mail, right? Now we are concluding our session here. In today's session, we have discussed various commands for inter-process communication, IPCS commands, how multiple processes are communicating with each other. Then after we have seen the mail command to send or to receive mail to different users, right? So we are going to cover some more advanced detail related with inter-process communication in next subsequent session. Till then, happy learning, keep practicing. Thank you.